Hello, my name is Claude. In this video I want to show you how to integrate Bitrix24 with external systems using Microsoft.NET technology and C#, Visual Basic or Python as the programming language. Intranets, firewalls and from outside not accessible servers within these firewalls will be considered in this presentation. It is an HD video, i.e. on the device where you are watching this video. Change the setting for YouTube videos to HD if necessary, so that you can see everything very precisely. On Windows, click on Settings to do that and then set the quality to 1080p. On an iPhone, press the three dots and then set the quality to 1080p. And not to forget, before we begin with the show, a key topic of the presentation will be massive enhancement of performance and throughput via parallel processing. Okay, let's begin with the show. Let's say we have a company with name Maxi Entertainment, which is using Bitrix24, the cloud version. Company Maxi Entertainment may also be using an inventory management system, a system for accounting and reporting, or maybe it is using a full ERP system combining all the functionality. These systems are inside of the intranet of the company, an intranet that is of course protected by a firewall. The systems in the company's intranet and their databases typically run on servers that are not visible from outside of the firewall. The company may also be using systems that are directly accessible on the internet. A typical example is an e-banking system. In this context, it is a good choice to have inside of the intranet a .NET application, typically written in C# or Python, which is interacting with the other applications. Such a .NET application has easy access to all the other applications in the internet, i.e. to their servers and to their databases, and also to shared drives. And of course also to applications that run on the internet. Such a .NET application can be a .NET web application, a .NET Windows Forms application, a .NET console application, or potentially also a .NET web service or a .NET RESTful service, to mention only a few of the possibilities. And since there is quite a variety of possible application types that can be used in this context, it makes sense to have the common code in class libraries that can be used in conjunction with any of these application types. One or multiple class libraries containing all the business logic or the logic to communicate with external systems, and one class library containing all the .NET Bitrix24 interoperability logic. Such a class library called .NET Bitrix Interoperability Layer makes it quite easy and comfortable for .NET and Python developers to interact with Bitrix24. All the complexity of the interaction is encapsulated in the interoperability layer, and the interoperability layer is exposing a quite simple, object-oriented and type-safe interface to surrounding programs. Okay, let's see this now in action. Here we have a small Windows Forms application called .NET Bitrix Integration. We double-click it. It communicates with Bitrix24 and it says your Windows user ID is Maxi CGR. That's actually me. User Maxi CGR is defined in Bitrix, but it is not allowed to carry out any of the provided functions. We click on Menu. And as we can see, I indeed cannot carry out any of the provided functions only the menu item start page is enabled. All the other menu items are disabled. So in Bitrix24 somewhere it is defined which access rights I have, which functions I am allowed to run. Let's go into Bitrix, Bitrix24 Drive, Company Drive, folder integration with other systems, and open Excel workbook access rights. Maxi CGR is defined here, but as visible without any access rights. Let's go into edit mode. And let's give Maxi CGR some access rights. I mark now get fields of CRM entities, get Bitrix deals, and also reconcile invoices with incoming payments. And click Save. This solution with the Excel workbook storing data of intranet users is really only for demo purposes. In a real-world application, the data should be either stored in a database outside of Bitrix24, or a list should be created in Bitrix24 storing and rendering data of intranet users. Okay, let's go back to our application. Click Start Page again. And you see now that menu items are enabled as set in the Excel workbook before. And now it's getting interesting. In .NET, you can run asynchronously and in parallel, whatever makes sense to run asynchronously and in parallel. In our example, we want to get deals from Bitrix24, deals including the associated product details. In order to achieve that, we have to make one HTTP request to receive all the deals according to a defined filter criteria. In our case, these are 10 deals. However, these deals come without the associated product details. So for each deal, we have to make an additional HTTP request to get the associated product details. These are 10 additional HTTP requests. In .NET, it is very easy to make these additional HTTP requests asynchronously and in parallel, and this in a totally safe and fully controlled way. Okay, let's have a look. We click on Menu, Get Bitrix Deals including product details. We only want to get deals that have been created after 3rd of November 2019. Okay, these are actually 10 deals. And we want to send the 10 HTTP requests for the associated product details in parallel. This is a simple XML representation of the data we receive. In the first deal, we sell chocolate and bananas, as you can see. 10 pieces of chocolate for $1.50 each piece, and 5 kilo bananas for $2 per kilo. Altogether, $25. Let's see now how long it took to get the product details of all the 10 deals when making the 10 HTTP requests in parallel. It took 693 milliseconds. Let's repeat. Around 600 milliseconds again. Let's repeat. Around 600 milliseconds again. Okay. Let's open Fiddler now, the network monitoring tool. to see more precisely what it means to shoot 10 HTTP requests in parallel. So let's shoot, and zack, you see it. The HTTP requests shoot in one, they go in one shot. Let's do it again to have some fun. Where is it? Here. Shoot, and zack, it's done. Okay. As a comparison, let's see now what it means to do it in the traditional way, meaning we send the HTTP requests one by one, or this actually means one after one. Let's go. And we see tick, 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 tick. Takes, of course, much more time to get it all done. And it is altogether more than 6,000 milliseconds, basically 10 times more. This is due to a typical characteristic of a server farm in the cloud. It is comparatively slow when dealing with an individual HTTP request, but it can easily deal with multiple HTTP requests in parallel. I mean HTTP requests that come in the same moment and are dealt with in parallel. Running things asynchronously and in parallel makes of course sense in many more scenarios. For example, bulk updates of data in Bitrix24 can be made in parallel, or data from various systems or databases can be collected in parallel, or multiple SQL queries to a database can be executed in parallel. The general concept behind this is the following. A broader task is broken down into subtasks, and these subtasks run asynchronously and in parallel. Each of the subtasks can be broken down again into further subtasks, which again run asynchronously and in parallel. And by doing all of that, the .NET Task Parallel Library is distributing the work over all the available cores of the computer to optimally utilize its processing power. And as already mentioned, this is not some sort of experimental technology. It is highly proven technology that is heavily used in the finance and in the trading industry. Good. Let's become very practical again. Usually data synchronizations or data reconciliations between systems are not triggered by human beings, which are clicking on a button of a WinForms or of a web application. They are happening automatically at pre-agreed times, for example, all 5 minutes or once a day. The Windows Task Scheduler is often used to define which scripts or programs should run at what time. Let's go to Windows Task Scheduler. Open the application. Open this folder. Here we have folder Bitrix. Within this folder we have get deals, the task get deals. It is usually running at some pre-agreed times. We can also run it just by clicking this run button, and you see it did. The output was produced and is showing here. And the background is the following. As already described in the introduction, there are various application types that exist in the .NET world. Here we called a simple .NET console application from Windows Task Manager, a console application that of course has access again to the .NET Bitrix interoperability layer and also to all the other class libraries. And now let's dig a little bit deeper and let's understand a bit more about the architecture of this whole thing. As already mentioned before, there is a .NET Bitrix interoperability layer, which is encapsulating all the interoperability logic with Bitrix24 and is exposing a quite simple, object-oriented and type-safe interface to surrounding programs. Let's see now concretely how to interact with the .NET Bitrix interoperability layer using this interface. We open Visual Studio, the development environment. Here we have the solution Bitrix integration, and within this solution we have the class library Bitrix interop, that's our Bitrix interoperability layer. We have this console app that we mentioned before. We have a REST service, actually only for testing purposes. And we have the WinForm Bitrix integration. Within this Forms application, we have the form getDeals, and we look here at the code behind and see here there is a method doWork, and in this method doWork, here we actually interact with the interoperability layer through this simple object-oriented interface mentioned. So what are we doing? We create an object of the class Bitrix_Deals, which is inside of the .NET Bitrix interoperability layer. We set one by one. If one by one is chosen in the drop-down, default is in parallel. You remember the show with the parallel processing. Then we add filters to the filter list. In this case, in our case, we say the Bitrix field create date should be bigger than the value that is chosen in the date picker. So why do we actually know that the Bitrix field date create is really has the name date create and this spelling? That's easy to explain. We quickly go here into the application menu, get fields of CRM entities. We want to have the fields of the deals. We run it. And here we see we get all the fields as they are in Bitrix of the deals. And here somewhere in yellow, I will explain a little bit later what this yellow means. We have the field date create. So that's the point. The fields can be taken from here, basically simply copy paste. We go back and call the method getDeals of Bitrix_Deals, which returns a list of Bitrix_Deal objects. Here we have set a breakpoint, and we want to see this now in action. Debug, start debugging. Okay, get Bitrix_Deals, all in parallel, get. The breakpoint was hit, the program stopped at the right place. When we hover the mouse over the object Bitrix_Deal list that was returned, we get a visual representation of the object. The object returned is a list of deal objects, and each deal object contains a list of associated product details. Let's have a look now at this class Bitrix deal. The class Bitrix deal has properties that have exactly the same names like the fields of the corresponding entity in Bitrix. Let's go to the application again. We received the CRM deals field list, and because there is some mapping in place, we see in yellow those fields that we use, i.e. where properties exist in associated.NET classes that have exactly the same names. If we want to add a new property to the class, we can simply do it by copying and pasting from here. Let's add, for example, created by ID. Let's run it again, and we see that created by ID is now included in the result set and also populated with data. The mapping is done completely dynamically and works perfectly as long as the Bitrix field names exactly correspond to the property names of the associated classes in .NET. Last but not least, let's see what happens if we make a typo or define the property with the wrong data type. By mistake, we added a small x here. Let's have Bitrix visible on the screen, and let's run the application again. We get a very descriptive error message, and this error message appears also in Bitrix. The idea is obviously that whenever an error occurs in the .NET application integrating Bitrix with other systems, the Bitrix admin is notified accordingly and receives such a nice descriptive error message. A few words to the chosen architecture, more from the project management point of view. Point A. Not all the software engineers involved in a Bitrix integration project need to be knowledgeable in Bitrix24. Only the one software engineer working on the .NET Bitrix interoperability layer has to know the Bitrix24 REST API quite well and how to interact with it using .NET technology. He will make it very easy and straightforward for all the other engineers to interact with Bitrix24 according to the specific needs they have. Point B. Because of the clear segregation of responsibilities that this architecture allows for, it is fairly easy to predict the effort that is needed to accomplish a smaller or a bigger task. Point C. Test automation with Microsoft's testing framework MS Test can be implemented quite easily when using this type of architecture. And at the end, point D, so-called agile development is fully supported when using this type of architecture, i.e. it is possible to deliver a solution to a customer piece by piece. At the end of the video, a few thoughts about developing such an application for a concrete company. In the context of home office, most companies are prepared to give employees or contractors remote access, typically to the company PC they are working on when they are working on site. For our purpose, exactly such a PC inside of the company's intranet is required with Visual Studio installed. And the developer, who can sit anywhere in the world, must be given remote access to this PC or at least to Visual Studio running on this PC. There are various possibilities to achieve this. With Live Share, for example, the second option can be implemented very easily and just on the fly. Finally, the application that is developed must be running under a user account that has all the access rights required. So, if you have any questions, either from the business point of view or from the technical side, please let me know. I will do my best to answer all the emails I receive. Thank you for watching the video.